Okay, to graph this function h of x equals negative the natural log of 5 minus 3x, we need to evaluate it at some values of x. And I started off with the value of x that makes the argument 0. And that's negative, well, I'm sorry, that's 5/3. When x is 5/3, the 3's cancel out, and then it's 5 minus the 5. So the 3's cancel, you have 5 minus 5, which is 0. So that's a significant point because the log of 0 is not just undefined. That's a vertical asymptote for the graph of this function then. So x equals 5/3 will be a vertical asymptote, a line that the graph gets closer and closer to without ever touching. At x equals 2, the function was undefined because 3 times 2 is 6. 5 minus 6 is negative 1. And logs don't eat negative numbers, at least not in this class. The log of a negative number is actually a complex number, but we're not going there for this class. We're only considering the real valued logarithm functions. So for us, logarithms don't eat negative numbers, so this is undefined. And in fact, it's undefined anywhere on that side of the asymptote. So undefined to the right of the asymptote. So this one rounds up to approximately negative 1.6. Anyway, there are the values along with the asymptote, and I'll circle the asymptote here. X equals that will help us graph the function. So now let's graph it. So this time everything seems to mostly occur to the left and below. So let's write the x-axis here. To the left of the y-axis and below the x-axis. So here's y and x, and we do go up to 5/3. So that's, let's go to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's negative 8. There's negative 2. And here's 1, 2, 3, 4. So 5/3 is equal to 1 and 2/3. So the vertical asymptote for this function is about 1 and 2/3. So this is it. That's the vertical asymptote. And it's x equals 5/3. Okay, let's plot the points that we have. At 2, the function was undefined, and it's undefined everywhere over here because the argument of the log is negative. So, and logs don't eat negative numbers. So, the action is all to the left of that vertical line, and at 0 we're at negative 1.6. So we go down to negative 3.4, so this is negative 1, negative 2, negative 3, negative 4. So at 0 we go negative 1.6, that's about here, the y-intercept. At negative 2 we go down to negative 2.4, which is about here. And at negative 8 we go down to negative 3.4, it's about here. Knowing that this vertical line is the vertical asymptote, we can now graph our logarithmic function. It's asymptotically approaching this vertical line and goes through those data points. So there we have it. That's at least approximately the graph of our function y equals h of x.